all of you, and I once again welcome to this particular track, which is on talking to machines, satellites for IoT, drone and autonomous vehicles. The hall is almost 75% full, so it shows what kind of interest people are taking in this new area. IoT basically is emerging, just started to emerge. So there is a lot of opportunities for startups and people who have already into some area to expand and to dive into this area and contribute. The industry has got a lot of things to contribute in this area. We have Dr. Govindrajan here, Aniara Space, and we also have Pradyumna here. He is from, I was thinking we are trying to design vehicles of Mach 7, Mach 8, but he is already Mach 33. So it is a hypersonic thing. And of course, I am Sastry. I will not be speaking on anything. I will only be asking them to explain what they are doing. I am basically working in DRDO. We have created a separate laboratory for defense satellites, that laboratory. And we also have Dr. Arunprakash. So,
from Satellite Applications Catapult.
Is a Catapult. So that I read. So we were in touch. So the time given to us is around 1 hour 20 minutes, but already 15 minutes passed. So we have around 1 hour roughly, let us say 1 hour 5 minutes. So around 10 minutes, so 70 minutes, 20 minutes I will leave it to the audience to interact with the experts, and I will ask a few questions regarding their contributions to this, their experience, and what they have to offer to us in future, and currently what they are doing. So one round will be there with the 3 people. After first round is over, again I will go to all the 3 people in the second round. And I feel maybe if audience wants to interact during their talk also, I think we can allow. Is it okay for you? Yeah. Yeah. So all the 3 people are experts in their areas, and they have a lot of contributions in the field of drones and vehicle to satellites and ground stations and IoT, basically for using satellite technology. So the order of the seating, I would like to first ask Dr. Govindrajan, what is your viewpoint on satellite-based IoT, and IoT, especially how it can be benefited by using satellites? It can be using terrestrial networks also, you can have IoT. But when we say satellites, what specific advantage you think satellites can offer in the field of IoT?
Basically, satellite, provides broader coverage. That means you can reach the place where the traditional terrestrial technology cannot reach. So that means the satellite is the one which can probably give you the confidence of continuous coverage wherever the satellite has got footprint. Maybe with your permission, I'll take yeah. Just going back to the basics. IoT, we are talking about IoT. Basically, it is network of connected devices and the technology that facilitates the communication between the devices. I'm talking the basics because of giving importance to 2 words here: connected, that is connectivity, and the technology. So whenever we talk about the connectivity and the technology, obviously we will have more than one. Terrestrial, if you want to call it as one technology, and connectivity should happen. So terrestrial technology has got a lot of advantages. It has got limitations of not able to reach the remotest places. Of course, we can make it happen, but from the business or economic point of view, we will not have the full coverage of terrestrial technology. So that means we need to look at some other technology, which I call as satellite technology for continuous connectivity. If I just want to take back to late 90s, when ISP was privatized, India opened up ISP, internet for private people to be internet service providers. That means they allowed the private companies to establish international internet gateway. But at that time, there was no fiber availability in the country. So that means we were depending on the satellite. I'm happy to say that I was involved in a company dealing with the foreign satellite, which provided international internet connectivity and helped set up the internet gateway. So when fiber was not available, people were liking satellite. 2 years later, fiber was available. Then people thought, that users thought that satellite becomes redundant because fiber offered very low price, low latency, things like that. Why I am mentioning that is, we should never think one technology will surpass the other technology. No technology will supplement the other. It only complements. So people who were talking about high latency those days, in fact now nobody talks about high latency even when it comes to satellites. There are LEO satellites which provide very low latency, almost like fiber. So having said that, we have to look at, in fact in the morning also maybe I would like to quote somebody talking in the morning session that cost, coverage, content. It's CC is very, very important. That means whenever we talk about the technology or alternatives, everybody will agree, then cost plays into picture. So cost, coverage and content. In the same way, I also want to use my famous 3 C's. Cooperate, collaborate and compete. That means whether it is different technology, terrestrial or satellite, I always believe that they should cooperate and collaborate, and of course compete as we move forward. So what I mean to say here is satellite plays an important role in providing the coverage, complementing with the available terrestrial technology. Then recent release 17, I think, of 3GPP, they have approved the use of satellite for such applications. That means there is a coherence between satellite and 3GPP, the terrestrial network. Coming back to next is applications. So, I don't want to talk about all the applications that IoT provides. It's sufficient for me to dwell on precision agriculture, transportation logistics, and passenger vehicles mobility. Why I'm mentioning all these things is, all these things require satellite. They are important, but need satellite because they're all remotely located. So terrestrial will not cover. That means we need to look at the use of satellite wherever it is needed. Why I'm not mentioning smart city, those kind of things, applications, or industrial IoT, we don't need satellite in such applications. So, if we agree the importance of satellite for such applications to cover, then we also have to look at the ground terminals, because cost, coverage, content. There are a lot of innovations that are happening on ground terminals as well. In fact, we have now ground terminals available for less than $100, modules that are available which can be integrated into the PCB for $30, things like that. So costs also obviously have been taken care by the people who are designing this satellite. One last thing I want to mention, whenever we talk about satellite, it's highly regulated in any country. That means we need to look at the regulation also. Like, obviously, every country will look into the national interest while allowing new technology or especially the satellite communication in their country. I always say that, in fact, this morning also the Secretary Telecom was mentioning that we need to be more adaptive. In the same way, when innovations happen in technology, we also need to be innovative in our regulation to make satellite connectivity available in our country or anywhere. It's not applicable to India. It's all regulation holds good for many countries as well.
Now, we have Pradyumna Vyshnav here. He has worked on something like autonomous vehicles, drones, robots, and some vehicle-to-everything technologies, things like that. And AI and ML also probably he has worked. Then anyway, now for the topic, this IoT, when you say thing, that thing means it can be a person, it can be a vehicle, it can be anything. Thing is really anything. Even person also is looked at as a thing only. Once he is enabled with some sensors and some networking capability and some communication capability. So, can we hear from you, how do we use satellites for precise navigation, positioning accuracy of autonomous vehicles, drones and robots, and anything in this area, what you have worked and what you expect in future that is going to come. Can you please let audience know your view on that?
Yeah, thank you, Dr. Firstly, I'd like to also thank SIA for giving me this opportunity to provide my viewpoint here. So yeah, I think I'm going to come in from an end user perspective here because of my background. What we see in robotic systems is that we will need to autonomously navigate these, let's say, robotic systems in various dynamic environments. And a lot of these environments are, let's say, not very suitable for robotic systems to go into because we don't have any prior information about the environment. So that's where the sensors come into picture, where we are using these sensors to be able to understand the environment before we go in and also process the environment. And GPS is one of the basic sensors or the basic data that we use in order to navigate a robotic system. But what happens usually is that there are areas wherein GPS is not very accurate. So we need to use additional sensors on board. For example, we use vision sensors, we use LiDARs, we use IMUs, and we do something called as sensor fusion, wherein we are fusing the data from an IMU with a vision sensor or an IMU with a LiDAR sensor. And by the usage of this fused data, we're able to get a more accurate representation of the environment. One of the experiments that I worked on a couple of years ago with the European GNSS agency was that what happens if we, let's say, fuse the data from a GPS constellation with a Galileo constellation? Is that going to give us more accurate results? What we found out was that once we use these fused data from constellations, we were able to get a very precise accuracy of these, let's say, drones that we were navigating in an environment that was not let's say, a priori we call, which is no information about the environment before we go into these environments. So we fuse the data from a GPS constellation with a Galileo constellation, which is not very, let's say, common, so to say, because everybody only uses GPS along with other sensors like cameras or LiDARs. So what I would like to mention is that because of satellite communications and satellite technologies, we were able to understand the environment better, and we were able to, let's say, also do dynamic obstacle avoidance, for example, wherein we'll need to in the real time, in real time, we need to navigate. We'll also need to maneuver the robotic system so as to not, go and tackle with obstacles or go and hit any human being, for example. And also, Dr. Sastry mentioned about IoT being, either of multiple objects of things or also people. So we have something called as human in the loop operations in robotics, wherein there is a human operator or an observer, but the human observer only comes into the loop when there is an emergency or when there is a rescue, a scenario. Otherwise, it mostly happens, all the tasks happen autonomously. And it is an interconnection of these different devices that we're talking about. So we have multiple robotic systems we call, what we call a swarm network, exploring a region. So there's communication between these devices, apart from the entire network communicating with the ground station. There's interconnection between these individual robotic systems as well. And therein we would like to have the satellite, let's say, data fused with more accuracy because of the nature of the exploration. And this has a wide range of applications, for example, in agriculture or in mining, in oil and gas, in space, because these are environments wherein we go into without knowing any prior knowledge, right? Because if everything is already given to us, then there's no need for us to be able to explore these regions. The reason of sending robotic systems into such environments is because we want to get a situational awareness before we send the humans, because humans, let's say, are not safe to go into these, let's say, extreme environments. So that is where I think we will basically need satellite systems, and in the future we are going to see that more of these satellite data will be fused, has to be fused. The constellations need to come in, and because of this fused data, we will be able to get more precise navigation and accurate positioning of, it can be a drone, it can be a robotic system or a autonomous vehicle. Even on the street, because of the richer information, we'll be able to avoid, let's say, accidents. Also, we'll be able to pinpoint humans on the street if it's an autonomous vehicle. And a lot of these applications have various benefits if we are able to get richer information. That only happens when there is accurate data from us, being provided to us from these satellites, and also along with those sensors that we have on board.
Thank you very much. I will come back to you regarding this in the next round. Now we have Dr. Arunprakash. He has worked on drone communications and other things beyond visual range. If it is visual or line of sight, if it is there, it is easy to maintain communication. But once the swarm or whatever group of things, when they happen to go across a wide area where the first one is not able to see the last one, and things like that. In this area, I think you have worked to some extent, and maybe a good amount of work you have carried out. Can you tell the audience, what is involved in getting beyond visual sight, visual or at least line of communication? How difficult it is to maintain the sequence and the handing over from one to the other? Are there existing any kind of protocols, or you are working on your own without any industry set standard protocols, or is there any standard? Have you evolved your own standard, or what did you do, and what do you think in future it should be done by the industry, so that I can connect and communicate with somebody's drone also, not only my drone? So can you kindly let us know your experience and your view on that? Thank you.
Thank you, sir, and thank you, SIA-INDIA, for this opportunity to talk here. So, the drone market is currently emerging, and according to PwC estimates, it said that there would be more than 900,000 drones in the UK airspace by 2030, which will contribute to around 45 billion to the UK economy. That's what the estimates are. In various number of use cases like delivery of goods, light goods delivery, medical goods delivery, monitoring purposes, and also for emergency response. So for enabling all these use cases, drones has to operate in beyond visual line of sight. That means Usually we operate drones with a remote control and we can see the drone and it directly communicates with the line of sight. But what is needed to enable beyond visual line of sight communication? And Sir has already covered when there is no terrestrial connectivity. For example, if a drone is flying over a water body, it has to connect to satellites. So that is there, Sir has elaborately covered it. But most of these use cases are going to happen in the urban areas or even in the rural areas where there will be terrestrial connectivity. So are satellites required, or what is the significance of satellite connectivity when the drones fly over in an urban area where there is already an existing terrestrial connectivity? And there has been significant activity within the 3GPP community to enable cellular connectivity for drones. And 3GPP has analyzed most of the things and whether it is feasible to provide 100% connectivity throughout the flight for drones just using terrestrial networks. So from a connectivity perspective, for cellular towers, drones are considered as flying mobile phones. It's a user equipment for cellular towers. So obviously for ground-based users, we have shadowing, we are obscured by buildings, we won't get a proper connection, but drones mostly fly above the towers or the base stations. So obvious answer would be, it will have a line of sight with the towers and we will get good connectivity. But that's not the case. In one of the projects which we have done, we have analyzed that. The issue is, the basis of cellular communication itself is the cell concept, because we can reuse the frequency in a neighboring cell where our mobile phone will not have a connection. But drone not only sees that base station, it sees all other base stations, because it has the line of sight path with all the neighboring base stations which use the same frequency. So it receives signal from different base stations. They are not actually signals, they are considered as interference. So the signal quality or the signal to interference plus noise ratio will be low. So even though we have a line of sight path with the base station, it will have a line of sight path with interference as well. So what we have analyzed is, what we've seen is, even though we have so many base stations, even though there is a cellular connectivity in a dense urban area, the drones might lose connection. So that's why we need a complementary. So we need hybrid terrestrial satellite connectivity. So we should have an intelligent router and both cellular transceiver, satellite modem on the drone, which can connect to either cellular or satellite according to the signal quality or according to the traffic. So that is the significance of satellites. And we have been doing multiple projects providing hybrid connectivity for drones. There are so many challenges, yes, but still we need both cellular and satellites to play a complementary role in the case of drone connectivity.
So, thank you, Dr. Arunprakash. Now I will come back to Dr. Govindrajan. What kind of applications we can think, okay, I connect 10 drones, 15 drones, or maybe few hundreds, but what kind of service they can provide, for example, agriculture, or for example, maybe public health, or some kind of management activities in the government, some observation of activities which are otherwise not observable. For example, I'm from defense area, so some terrorist is hiding somewhere, I cannot see, but then I can send a drone and look at, but then one or two. So these kind of applications in the common interest for a common man, because applications like space and defense, they are quite a few and restricted. Users also will be restricted. But if you look at agriculture or mining or these kind of public activities where a lot of money is involved, what specific applications you see in near future these things are going to come? Because the other day I went to Ahmedabad for a defense expo. Every other alternate stall is having some drone, some kind of the drone or the other. So it is going to explode. But then what do you see for a common man, how these services can be put? Can you just elaborate on this, please?
Yeah, you're right. Whenever you think of drones, generally, of course, previously drones was So subsequently, the drones have evolved in the last few years. In fact, you have a lot of drones companies coming out, and also government is also giving a lot of encouragement to that. As you rightly said, the drones, one of the primary applications is for surveillance, obviously. Leaving that apart, it can also be used as my friend was mentioning. You can pick up the signals in many areas like our agriculture, precision agriculture. You can pick up the signals from the sensors for any precision agriculture. I'm stressing precision agriculture because you need the data also, precision data for converting that data into some analytics and give it to farmers and the other stakeholders to have an efficient crop of production. So that's one thing. And second, even when I say agriculture means a lot of parameters are including the weather data also. So oil and gas. So again, why I'm mentioning these things is these are the areas where you need satellite. You don't have terrestrial going there. Whenever we talk about agriculture, generally it's in the remote areas. So oil and gas also, you require the precision sensors. The data will of course can be picked up by drones and communicate to the data loggers or whatever. Another thing is fisheries. So fisheries is one of the main applications, marine applications. Similar to whatever I mentioned, precision agriculture. Same thing in fisheries also. You can collect the data through the sensors and communicate with the drone.
Now, if you look at, say, vehicle to everything, or vehicle to vehicle to that thing, which is maybe autonomous, maybe independent, or whatever it is. So that is also very important that it gets connected to, see, for example, if somebody is traveling, I would like to see what is happening to him, whether he is, kidnapped or taken away or something like that. What kind of technology we can equip, with our vehicles, which can directly communicate to satellite, or maybe a group of satellites, a constellation that can continuously monitor and ensure the public safety, public, security is more. That is also very important. Recently, of course, nowadays it is not there, but we have heard this people like some drivers of Uber and all kidnapping the lady passengers and doing whatnot antisocial activities. So do you think vehicle to everything in your area of work, have you seen how can you provide security for common people so that they can easily hire and just go, and monitorability, like of course today WhatsApp I can enable live location and people will see, but then the phone can be snatched. So a vehicle by itself in untamperable way has to be fitted with certain security features, in my opinion. Have you worked on anything with autonomous vehicle for its navigation and also the passenger safety and security and surveillance? Can you say something about this, please?
Yeah. So I think this area is quite rudimentary at this point, especially in India. I have not really seen any applications wherein we are using vehicle to everything. Even applications which involve swarm technology is quite limited at the moment, and a lot of these research is only happening within academia or advanced research labs, let's say within NASA or Lockheed Martin or Airbus and so on in the space sector. Or on the autonomous vehicle side, it's probably happening at Cruise, GM, Argo, the top autonomous vehicle companies. But I would like to point out three major advantages of utilizing SATCOM, integrating satellite communication with terrestrial and digital technologies. The three major, I would say, benefits that we would accrue are, one is resiliency. So resiliency is about robustness of your navigation system, of the precision, the precise, let's say, pinpointing of your vehicle. That is the resiliency with which you can say that your vehicle is at a certain location. And the second is safety and security. Now, like Dr. Sastry was mentioning, safety and security is one of the predominant, let's say, issues when it comes to anything that is programmable. Right? Anybody can hack into it. It's a concern that has been expressed by a lot of people. Now, when you're, let's say, providing an additional layer of security for these systems by utilization of SATCOM, by utilization of other, let's say, technologies that act as a filter so that nobody can hack into it, safety and security part is taken care of. And lastly, autonomy. Now, autonomy has various levels to it. A lot of people seem to misrepresent automatic vehicles with autonomy. They're quite different. So, just to give you a small example, a drone that is following command and control, which we called C2, it's a predefined path that we're giving to the drone, whereas a drone that is autonomous doesn't have a predefined path. So, a drone that is working on, or the drone that is basically, let's say, operated with C2 commands is automatic. An autonomous drone needs to learn in motion. So it's a dynamic way for the drone to adapt to the situation in real time without any external input. So these different levels of autonomy needs to be understood clearly. That's why we have level 1 to level 5. These days we are talking about level 5 autonomy in autonomous vehicles in urban environments. Right? So that is very hard to achieve because it's basically really difficult to teach any action to a robotic system. Every action that we teach to a system, the robot performs only that action unless there's a component of AI or ML that is in the loop, wherein the robot or the autonomous system is able to self-learn based on the environment, based on what is able to grasp from its surroundings, which is where we put in these sensors. Apart from that, if there's no, let's say, self-learning, or if there's no ML running in the background, in the loop, then it's very hard for us to be able to autonomously navigate these systems, because there are two problems here. One is we need to understand where we are. So as a human being, I know my, let's say, orientation, my coordinates. So I know I'm in this room. So I can go from point A to point B. Now imagine a robot which doesn't have a cognitive ability. It doesn't know where it is. So we'll have to teach the robot where it is, which we call localization, and where to go. So we call something, we use something called as SLAM, simultaneous localization and mapping in robotics, wherein we are simultaneously telling the robot where it is in the world space and where it needs to go. So we tell where it is by the utilization of sensors on board, and then we map the environment and tell the robot to go from point A to point B. So this is a very complex problem in the industry at this point, and a lot of universities, top universities in the world, best of the brains are working towards solutions wherein we are able to autonomously navigate without any hiccups, right? So taking all this into consideration, I would say that the vehicle to everything technology is still quite new, and it will take a lot of, let's say, development in various technologies. It can be on the digital side of things, on the AI side of things, on the IoT side of things, on the SATCOM side of things. So there needs to be an integration that is happening, between these technologies. So AI needs to be integrated with robotics, which needs to be integrated with IoT, which needs to be integrated with Swarm. And unless that integration happens in the ecosystem, and there's a layer of security, there's a layer of resiliency, and a layer of autonomy that kind of encompasses this ecosystem, it's very hard to have a commercially viable, it's easy to do this in a lab, right? So a professor can have his PhD students working in a controlled environment. He can have 5 different robotic systems. It can be a drone. I've done this myself as well, where we have interacted with, a drone has interacted with a ground vehicle, which has interacted with another ground vehicle, and we have multiple systems working in a lab environment. But then once you put this on the street, there are a lot of edge cases that you cannot foresee, you cannot simulate. This is one of the biggest problems in autonomous vehicle industry today, is the edge cases, right? So there are millions of edge cases that is impossible for us to predict. So the only way the robotic system or the autonomous vehicle will be able to adapt to these edge cases is if it is able to do real-time learning, if it is able to do imitation learning, if it is able to do the learning based on its surroundings, and that is what everybody is working towards. But I think it's still quite, let's say, in the initial phase. I kind of see this happening, let's say, in the next 5 to 10 years. But until then, it's very hard for us to work on these technologies that have a commercially viable product. But in certain use cases, let's say mining, for example, or taking from Govind sir's use case of oil and gas, slightly, let's say, sister use case would be maritime, wherein we are going to have these technologies used for navigation of drones from onshore to offshore locations. And this is a very lucrative, let's say, use case within the industry, because it's very costly for these ships that dock at certain kilometers away from the port. They have to use smaller ships to be able to transport these goods from each port, and that is a costly affair. So if we are able to create, let's say, or build a drone, one of the companies I worked previously was doing this, when we were creating drones that could carry goods and other equipment from onshore to offshore, and that is where I see like a real use case of GPS plus sensors on board, because a lot of these locations in the sea, GPS is not very accurate, so we need additional sensors on board. And this is something that the industry is looking for, and it's a use case that we can use multiple robotic systems. We can have a swarm of drones going from onshore to offshore and so on, wherein that is possible, but very limited use cases as of today. But I definitely see this becoming more, let's say, mature in the next 5 years.
Coming back to Dr. Arunprakash. See, a drone is characterized by its payload capability, how much it can take, and also endurance capability, like how much time it can fly without recharging those batteries and things like that. So equally important is the energy source for the drone to fly, and the power and endurance and things like that. So do you see the existing lithium ion cell, I'm digressing because I am finding maybe people, it will be of interest to know, the drones what you have dealt with, what was the largest capacity that it could carry, and what was the endurance time, and what do you think in future? Say for example, see in cities in India, it is very difficult to, traffic jams and everything will be there. Most of the time we create a green corridor for transporting heart or something like that from one city to other city. And what do you think doing this kind of operations? Right now, what is the capacity of endurance and payload capacity? And what do you think in future it will be required? What will be in the next few years? What kind of technology developments in terms of batteries are required? And how long you think will be the need of a common man maybe in the next maybe decade? Can you just tell your viewpoint on that?
Thank you, sir, for the question. So that's one of the major challenges that we face when we try to provide satellite connectivity to drones, because what's the size, weight, and power requirements of that terminal? Because the satellite terminal can be bulky, and another, the drone should be able to carry it, as well as it should not interfere with the aerodynamics of the drone. The drones are not just vertical takeoff drones. It can be even horizontal takeoff drones as well, unmanned aerial vehicle. So that's an important issue. So that's where we need to have such small, compact terminals that can be implemented on the drones with less weight and less power requirements, and also which will not interfere with, which can be compactly packed on a drone, and also which can provide connectivity. Not only that, we also need, we cannot use a single terminal or single antenna which can be used for a multi-purpose like terrestrial and satellite connectivity, because the one antenna will be on the top of the drone and the other antenna should face downwards. So we need multiple transceivers as well on a drone. So all these things are going to increase the size of a drone, or the weight of a drone, or weight of the terminals that a drone needs to carry. So that are still such challenges, And regarding the charging, I'm not an expert on that, but still I can comment on that. Some of the things which currently we are looking at is how to wirelessly power a drone. That is a big project which we are doing. It's actually a space-based solar power system. How to wirelessly transfer solar energy from space, a satellite converting solar energy into electromagnetic waves, which is received by a very huge rectina on the ground, which can be scaled down, and that technology can be in future maybe used to wirelessly power a drone. There are also solar powered drones, but there is a limitation to the weight that it can carry. But if we can wirelessly charge a drone, that would be the best possible solution. There are some drones which can fly for a number of hours, because mainly one of the use cases which we looked at is light goods delivery use case. For example, Amazon, they have a same day delivery, but with a drone it will be same hour, 1 hour delivery. Within an hour we can deliver goods. So we have drones with such capabilities which can fly for some hours carrying a particular weight. Still, there are some additional challenges, as I have said. We need to have more robust modems, because at different stages of flight, the drone can have different pitch and roll angles. So it might lose, or it might have a low angle of elevation with the satellite. So we need multiple transceivers, additional signal processing, and more advanced waveforms to enable this seamless operation of drones. And one more application, from a connectivity perspective, drones will be considered in the future as part of prospective 6G architecture. It's a 3-dimensional architecture where we have satellites, a middle layer of drones, and cellular base stations. All together will be an integrated hybrid 6G architecture. And then drones will play or will act as base stations or as relays in an integrated terrestrial, non-terrestrial system. So that's a prospective use case of drones from a connectivity perspective.
Thank you. So this will be my last round of discussion with each panelist. So lastly, what kind of ground stations, you are expert in ground station building and maintaining. So existing infrastructure of ground stations, is it okay? Or you need massive infiltration of these ground stations to support the operations in future? And what do you think people in government should do to see that? See, once you throw everything everything you are connected to internet, and you are totally depending upon them, and there is a very great possibility of criminals also entering into that and doing. My mind always works like that, so I cannot stop that. See, like cyber crimes, if you have a very nice way to transfer money from your phone to somebody here. It has done a nice thing, but it has also created possibilities of somebody stealing your money, maybe with your compliance or without your knowledge. So what do you think we should do to, some rules have to be framed and certain security features have to be incorporated in the communication so that they are secure and they are self-secure sort of a thing. So can you say something, two things, one is about ground station, another one is the government. What you think government should do to do these kind of regulations? Is there anything in place in other countries, or they are also evolving?
As far as ground station is concerned, especially for the LEO constellation, ground stations are very minimal. So that's one of the reasons. In fact, for the GMPSCS satellite, for companies like Iridium, if they wanted to establish ground station, it used to take $10 million, something like that. So therefore, they were always arguing in any country, why should I establish a ground station in each country? Because every country, not only India, every country insists that, okay, you should have the ground station in my country because whatever I transmit should come down before it gets distributed for security reasons. But now the IoT satellite operating the LEO constellation don't require an expensive ground station, number one. Two, just to give an example, recently I heard Malaysian government, during COVID, it seems they found shortage of food because they could not get food imported into the country because of the sluggishness in the movement of goods during COVID. So government, what they said is that we will fund the industry to come out with a plan and suggestion to increase the crop productivity and also suggest what type of crop that needs to be grown to increase its productivity. This is one example where I could say that government have come out with. So what it helps is the smart agriculture or precision agriculture segment will grow. Obviously, the stakeholders, including the vendors, satellite providers, IoT service providers, they all flourish because of the government support. And you mentioned about the other thing, crime, security. That's always there. So that's how the defense mechanism works. No? If you develop something, there will be somebody else to defend themselves on the missile. So security, crime will always be there. Obviously, proper security mechanisms will always be built. So.
Okay, Mr. Pradyumna, you were talking about having GLONASS, GPS, and maybe IRNSS, all this kind of constellations we do. You said you can fuse the data and get better accuracy. You have working this multiple, GNSS systems to improve the accuracy or maybe to improve the availability of the signals and things like that, and the general accuracy given by or the location accuracy of maybe 10 meters or whatever, is it sufficient or you have to reduce it to maybe sub-meter or things like that? What do you think? By combining this many things, can we get a sub-meter resolution or we cannot get? Because sub-meter navigation is a light use of especially for military purposes only. It's not available for public in common. So what do you think for our normal navigation also? Even using GPS, I want to go. Definitely we need sub-meter accuracy. Otherwise, 10 meters is not sufficient. I'll hit 3 vehicles within 10 meters in Indian roads. So what do you think this kind of fusion? What is your experience in getting a better resolution by fusing the data from various things?
Yeah, so I would say it's a bit of both. One is the non-availability of reliable data in certain regions, and the other is the aspect of getting accurate or higher accurate data with a fused system. So basically, when you say sub-millimeter, a lot of applications require sub-millimeter level accuracy because of the nature of the use case itself, right? So let's say, for example, you're doing autonomous operation on Mars. Right, so you have identified a certain location on the region wherein you will need to go, and this needs to happen without your intervention because it takes about 20 minutes for you to send a signal to Mars, 20 minutes for you to get it back. So there's a 40-minute delay as it is, which means that you cannot tell the robot what to do in real time. Right, so we need to pre-program the rover or the robot on Mars to be able to have this sub-millimeter accuracy to go to the precise location wherein we need it to go, because it's a science mission. So the locations are defined by scientists based on the area of interest. So a lot of these regions, for example, such as caves, are still inaccessible for us because the rovers are not able to access those locations because of the nature of its mobility. Which is why, for example, the Ingenuity mission by JPL, which was a Mars helicopter, which was the first time in the history of mankind a drone flew on another planet. The reason for coming up with such technology is because we are not able to reach those actual interesting areas or regions of Mars, of Moon, of planets, other planets that we want to explore, or the moons that we want to explore. And this is only made possible by utilization of sensor fusion, wherein we are able to get higher accurate data, higher accurate resolution. The reason being that each sensor has its own limitations and advantages. For example, a vision sensor may not work very well in low light conditions. A LiDAR sensor may not work very well in reflective, surfaces. So we need to come up with a mechanism or an algorithm wherein the robotic system or the autonomous system is able to choose the sensors on board through which it is able to decide which one it wants to go with. And the fusion of these sensors, as we have seen, based on the research that is currently happening, based on whatever we have already published in the academia, in the research, in the research, let's say, world, also within the commercial applications as well, we have seen that when we use multiple sensory modalities compared to a single sensor, let's say, system, a multiple sensor modality system works better. So, for example, Tesla is still using only computer vision for driving its autonomous vehicles. Tesla has abundant data, has millions of hours of data that is captured from its normal electric vehicles, but still they are not able to come out and say that we have level 5 autonomy, we are able to roll out these vehicles on the urban streets of San Francisco or Los Angeles without any problems. They have a lot of issues. The reason being, Tesla, I mean, it's their, let's say, prerogative, but they seem to think that it's possible to autonomously navigate a vehicle with one sensor on board, whereas another company like Aero is using multiple modalities on board, which they seem to think is a better way to go about solving the issue. So what we've seen is multiple sensor modalities definitely will provide us a higher accuracy, and there are regions wherein we call DPS denied navigation. GPS denied navigation is something wherein there's no GPS at all, right? Indoor environments. Let's say you want to have a drone that is flying in a warehouse to do some warehouse, let's say, maneuvering or some barcode detection in a Amazon fulfillment center. Now this drone or this autonomous system doesn't have any GPS because it's indoors. Now every, let's say, navigation capability of the drone needs to happen from the onboard sensors that they have incorporated. So it needs to have like a camera, it needs to have like an IMU. So these GPS navigation, let's say, systems are very, very hard to navigate, very hard to also design and develop, because there's no backup for us. Even if the drone fails, based on the sensor that it has, it needs to have a redundant system on board, otherwise it will crash. So from my perspective, it's very beneficial to have multiple sensor modalities to achieve sub-millimeter accuracies. We have been able to do that in certain, let's say, very advanced use cases, but at let's say commercial level or at a very wider use case perspective, it has not been able to come out much. They have not been able to roll out these technologies as much as we would like it to be. The reason being, it's very hard to devise such technologies wherein we are able to use data from multiple sensor modalities and also make it commercially viable without any, let's say, failures in the real world.
So, one more last time to Dr. Arunprakash. You were saying about when drones are trying to fly high and you receive from 2-3 mobile stations and there is interference in terrestrial communication, like signal collision and frequency management locally and maybe globally. So what kind of problems you have faced when you are in the field of you have 2 or 3 cellular terminals simultaneously, where you have got into this problem, and how did you overcome this?
So that's one of the problems when the drones fly above the cellular towers. First issue, what we thought would create a problem was, usually the antennas on cellular towers have a slight down tilt, because they are optimized to serve the ground-based users. And so we had apprehension whether the main lobe of the antenna, main beam, would be pointing towards ground and the drones are flying high. But since there was a line of sight, even the sight lobes could serve the drones. So that's one of the reasons why the interference was not very severe, because even from other base stations, it was the side lobes. But still, this received signal power and the interference power, both are high. So altogether, it's not just 2 or 3 base stations. We actually had the actual base station data of a region called Milton Keynes and did the analysis with the system parameters corresponding to different base stations, and it was giving no connection at all at certain points, even though it was nearby different base stations. So one solution is intelligently switch to satellites, because if you want to just send command and control data, it's a very small size. With the current solutions, it's possible, but if you want to send an application data like a HD video, it would be difficult because if you use a satellite terminal, and it would be difficult, but still it's possible. That's another issue. Another issue which we found was when drones communicate to base stations, drones will communicate to base stations, and for base stations, drones are user equipments. Even the drones are seen by other ground-based users on another cell. So now earlier the drones were victims. Now the drones act like aggressors to other mobile users on ground, because they will create interference to neighboring ground-based users. And so both uplink interference, downlink interference, and downtilt of the antennas. And one of the prospective solutions which are recommended by the research community, and which will be one of the prospective technology of 6G, is to utilize reflective intelligent surfaces, RIS, or intelligent reflective surfaces. It's also called IRs, where the base stations will have a down tilt. These are passive elements which can be placed on grounds or buildings, which can reflect the signals vertically, so that, or without causing interference to nearby drones or nearby base stations, nearby users. That's one of the solutions.
The people, please. The people who want to ask can first introduce themselves and what they are doing, and then ask the question, so that the panelists can address relevantly with your background.
Good afternoon, everyone. My name is Hamza. I represent an American company called Orca, and we are globally leading the market in satellite IoT, serving this from last 20 years. Already have 3.5 million subscribers.
You kindly also tell to which panelist you are addressing.
To the entire panel, basically. So, because we do completely on satellite IoT, everything.
Okay.
Right from tracking marine vessels to AIS to drones, power grids. And we do a lot of satellite IoT. And my question was that which industry in India do you think needs to mature for using satellite IoT? Of course, oil and gas, maritime, marine, and mining is something which already is using. But what other industries we can focus? Drone is something which is coming up just now. And yes, we have already deployed a few trackers on drone as well, dual mode GSM plus satellite. So what do you think? I mean, which other industries will have future in satellite IoT within the Indian market?
The applications will always evolve. If you provide the connectivity, applications will always evolve. Like when GSM was connectivity was provided, then only actually GSM was given only for mobile, the voice communication basically. But except voice, everything else got developed. In the same way, when the connectivity is provided, people will think of applications that they need. One of the examples I can give is, for example, there is a milk federation. They just wanted the satellite-based IoT solution to help them. You know what happens with the different milk vendors located in different villages, remote areas? They will go and milk to the collection center. They just want to collect the data, how much they have given, the quantity, and also use the sensors to measure the quality of milk. That's one good example. In fact, I also asked, why can't you use terrestrial? They said, no. The milk vendors, they come from remote areas, so and there will be a lot of collection centers within their cluster, and they want to measure these parameters for that. They wanted satellite-based IoT services. So I don't know, it's very difficult. People say that nearly 20% of India is not covered by terrestrial.
I think you can continue this discussion during lunchtime.
Yeah.
So we should give opportunity to.
So, roughly 20% is not covered by terrestrial. That's
Yeah.
common.
Thank you, Dr. Sastry. It is a nice panel. A lot of information is given. I am Satyam Gupta. I am Secretary General of ITO APT Foundation of India. My question is to our friend Govindrajan ji. I know him for last 30 years. Regarding this, what Mr. Amja was also asking, new applications. One application which come to my mind is the smart metering. Like country have decided that each meter of the country, and which is 250 million in numbers, should have a remote measurement or remote metering facility in years to come. So I was thinking this whether a satellite-based communication, low bit rate, IoT can help here. But only thing, the challenge, what I want to know whether it is true or not, because the meters are indoor in fact. So can a communication happen from a satellite to an indoor device and the metering be done?
Right. Thank you very much. Actually, when you asked other applications, I should have mentioned that as well. Yeah, satellite-based IoT services definitely helps in the smart metering applications. In fact, we are working with one of the service providers like Artcom in Brazil to provide smart metering services. So that's one of the very good applications for satellite-based IoT. So we have got a use case for that we could discuss maybe.
Whatever have been flagged will be addressed. But my question is, sorry, like we mentioned about applications like precision agriculture and the rural areas being the main target. Now, my question is on the commercial viability of the satellite solution. I mean, as compared to BharatNet also entering into the domain in the rural areas, which might take maybe another year or so. So how is commercially the satellite services placed? Because much will depend on that. Thank you.
As we discussed in the beginning, the cost coverage content play. First, we always expect coverage. When we satisfy coverage, cost comes into picture, obviously. And these are narrow, they use very narrow bandwidth, few kilobits of data only. Just to tell you, contest that, the cost of, for example, terminal which Dr. Sastry asked, cost less than $100. Cost of terminal, that's the one-time cost. And the cost of recurring, whatever, bandwidth cost if you want to call, shouldn't cost more than $10 a month.
No, my question was relative thing. Ultimately, when a farmer has to buy the precision agriculture solution, he look at the relative pricing. I mean, that was one question. And there are some applications where you can't use low data, like the application Pradyumna mentioned. If there is to be machine learning also for some of the applications, under that condition, the data consumption will be high, and it will not be possible will it be possible to compete with, the terrestrial one? That's
true. With due regards, farmers are not customers here. Farmers are users here. So customers will be different. Could be government agencies, could be even panchayat. Those kind of people, they are the customers. They will get the data and get that analyzed and give the output of that analysis to farmers to do whatever they want to increase their crop efficiency. And whenever we talk about the cost, we also should cost about the cost and availability. If we are talking about the satellite to serve remote areas, so obviously we are talking where there is no terrestrial thing is available. In fact, the turbines what we are talking has got interface both to satellite and to terrestrial, that is 4G. The sensors output when it comes to the satellite terminal, it sees if there is a 4G connectivity available, it goes to the 4G and goes to the server and data logger. If there is no 4G connectivity, it goes to the satellite and then go to the data logger and cloud server. So that means you need satellite where there is no terrestrial connectivity is available. Generally, the cost of whatever we are talking is comparable to terrestrial. If not, if there is a marginal difference, the availability ratio to requirement matches that.
So the time given to us is 13:20, so we are approaching with 1 minute left. So one more last question can be done. The rest of the questions, panelists are available and lunchtime is there. So I think one more question.
Yes. I'm Chandele from Geospatial World. We are evangelists for geospatial technologies. To Dr. Arunprakash, may appear a simple thing, but what if the terrestrial option is doubtful, then why not remain on satellite all the time, firstly? And secondly, what is this concept of pseudo-satellites? Can they help in this system?
Thank you for the question. That's a really great question. Actually, still there are some challenges to provide always the satellite connectivity it has to complement each other. That's how, because one of the main issues which we faced when we tried to connect it to satellites was different flight stages. The drones are going to fly at a very high rate. It's very high speed. And suddenly it can lose its visibility with the satellite. So at that time, it should have the diversity or it should have multiple transceivers. The solution is not yet mature. The terminals on the drones. We need small terminals with multiple antennas, and we should be able to do beamforming as well if you want to connect it to your satellite. So there are some existing challenges. Once they are, if we overcome those challenges, definitely we can use satellites. And HAPS will be an option. HAPS will have a low latency as well if you want to connect. So HAPS will be part of, HAPS in fact will be considered along with drones for the 3-dimensional 6G architecture.
Thank you. Yeah, with the permission of the chair. Okay, I am General Anil Kapoor. I am doing Professor of Practice at IIT Tirupati and also part of their Technology Innovation Hub on Precision and Positioning. So we've been discussing, all these issues which are there with problem with the terrestrial systems and satellite systems. Proliferation of satellites is definitely an option which I'm sure ISRO and others are looking at. But when we did a little study, we realized that quasi-satellites today, by virtue of drones, if you have drone panels which are made out of solar elements, the advantage that accrues to you is that you have an eye in the sky. It's a follow-up to what Jan Chandele said, that today let's take NCR as an example. If we had...
No, but what is your question?
Yeah, if we had such systems which are quasi-satellites which actually form a layer above the terrestrial and below the satellite, using solar-based systems, I think we should be able to pinpoint and precisely and give a position fix of every kind of application that we look at by just hosting a number of such quasi-satellites, as I call them, and come up with a solution. Do you think that's an option in a satellite, a quasi-satellite IoT-based system, which is, like I said, above the terrestrial and below the satellite as such?
Generally what happens is what you have suggested is only local area. Now if you want to coverage wide area and maybe cross entire country, if you want to provide, this is not a possible solution. Maybe for a local area, if you want to do something.
Let me clarify this. See, we do have some critical assets. It need not necessarily be pan-India, but I am saying over a period of time,
looking at the costs that a quasi-satellite has, which is much lesser than a proper satellite launch. The other is, actually you could get it done because it's just a drone actually in a way. Do you think that's a doable proposition, looking at the technology landscape that exists today?
That precise positioning, even with 5G base stations, if you have a drone surrounded by different base stations, the precise positioning can be estimated. The position can be estimated with millimeter waves. With just one base station, we will be able to exactly pinpoint where the user equipment or the drone is. But that will happen with massive MIMO, millimeter wave, very focused beam. We will be able to say exactly where the position of that user equipment will be. So we have a solution.
One more last question.
Thank you, Mr. Govindrajan, for referring again to my cost, coverage and content. I'd like to just refer to content briefly, if I may. It seems to me that all these technologies are great, and I think lots of opportunities in these areas, but if we took a content lens to them, we might generate more demand overall. If we think about data analytics, the power of the data that comes from these objects, IoT or drones, we might be able to provide bigger opportunities. So my question is, given others who referred to things like productivity, how can we give more attention to the content side and the data analytics side in this area? These are key market drivers in my view.
So there are two aspects to it. One is collection of data, one is analysis of data, right? So you're talking about the second part, which is analysis of data. Now there are companies which are working on the collection itself, there are companies which are working on the analytics part or the side of things. Now we need to use, let's say, technologies like AI or ML to process this data. Some applications need the data in real time. For example, one of the, let's say, crucial use cases I see becoming quite fruitful for the Indian context, also to answer Hamza's question earlier, is emergency response. Now, during COVID, we kind of came face to face with the fact that India was very ill-equipped and unprepared for an emergency scenario. And if we were to utilize technologies like satellite IoT, swarm network, or robotic systems, drones, AI, ML-based data analytics, to predict, let's say, the weather, the floods, or to predict, let's say, a calamity, a natural calamity, and to actually utilize the data that we receive from these collection of agents to process them in a manner that will provide us information before something happens. So that is called predictive, right? Predictive, let's say, maintenance or predictive analysis. So I believe that has a huge, let's say, impact and a huge advantage. There are companies in India currently working on such technologies. There are companies like Pixel, for example, which is putting a constellation of satellites in the orbit around Earth, and they want to analyze the data and provide that to agriculture, provide that to oil and gas, provide that to mining and so on. So this has a very useful, let's say, it plays a very useful role in really helping the common man or the masses. And I believe, as a final note, that's the whole objective of space should be, that it should be able to provide some sort of a comfort, some sort of a use case for the common man, right? So otherwise, exploration just for the sake of it is kind of fun, is very good, is good for us to do that. But then until and unless it really helps the common man, I don't think that makes really any sense. And analytics is the, let's say, is the cog in that wheel, which is helping us to analyze the data and provide it so that there is actually some kind of usage of data within the applications that is reflected in our daily lives. So I agree with that, yeah. Thank you.
I think your question is very lengthy or brief? Please.
Data, as far as we are concerned, forms the backbone of all analytics. and somehow in India there have always been challenges to access to data. The good part is that the drones are providing that. The advantage of drones over satellite is because satellites generally have been considered a very elitist kind of a arrangement where a lot of software and hardware is required to kind of process it, whereas drones have made it more easily accessible. But the challenge is that when we are taking data for say industry level exploitation at a large scale or a national program level exploitation, the data is not available in a consolidated way. They are available in penny pockets, isolated areas managed by different drone companies or institutions which have funded them. So I think we also need to look at it as a whole of nation approach, how this data consolidation can take place for the common good. That's my point of submission.
Very nice of you. And I think I have no problem. I can sit here for 1 more hour. But we have to leave the session. Maybe some other session will start and we have to take lunch. So I think we have done one thing I want to say is the panelists are extremely knowledgeable and they have shared their experience. I think it was for some benefit of the audience here. And I personally thank each one of them, and I thank SIA to have given me this opportunity to come and learn a few things. Thank you so much, SIA organizers, and I thank wonderful audience with their questions. I mean, we have understood the interest what common people are showing. So with these few words, I say that the session is closed. Thank you very much, and let us have a great
Thank you, sir. Quite an interesting conversation. I hope you all jotted down your notes and took insightful ideas from this session. Also, I would like to thank our chairperson and following speakers for active participation and their inputs in this session. Now, I request our chairperson, Dr. Srinivasa Sastry, to felicitate our speakers with mementos to Dr. Arunprakash. Thank you. To Mr. Pradyumna, Vyshnav. And to Mr. D.S. Govindrajan. Also, I would like to call Mr. Rajat Ali, who is our Senior Advisor in Radio Regulatory Affairs, to give mementos to our Chairperson, Dr. Srinivasa. Okay. Thank you, sir. And now it's time for our lunch. To join us in networking lunch breaking, which is in a pre-function area, the Desire Hall, outside the Desire Hall. Our lunch time is for 1 hour, 10 minutes. So please join us for the next